Hello everyone. So again we are integrating a function x square plus y square using spherical coordinate where the region is a sphere and it is cut by a cone. So step 1, to sketch the region. So S is portion of the sphere, that is x square plus y square plus z square equal to a square, cut by the cone x square plus y square equal to 3z square. Okay, so if we try to plot it, so we have something of this form. So we have a sphere with center 0 and radius a. So we have something like this, and it is cut by a cone. That means something of this form. So a cone like this. Okay. So therefore we are going to consider this region which is in front of us. That means in the upper hemisphere this part, and in the lower hemisphere this part. Okay, so we need to determine what will be the angle. We know that this is nothing but x square plus y square by 3 equal to z square. That is the cone. And this is a circle sphere, x square plus y square plus z square equal to a square. These are the boundaries. Alright, so now we will use spherical coordinates. So we know spherical coordinates are, so spherical coordinate we know x is equal to rho cos theta sine phi, y is equal to rho sine theta sine phi, z is equal to rho cos phi. Alright, and without fail we have to take the Jacobian, that is rho square sine phi, because we are moving from xyz plane to rho theta phi plane. Alright, so next is we want to determine the angles and all, and we know that we are considering a sphere of radius a. So in our case, the range for rho will be where 0 less than rho less than or equal to a. Okay. And for determining theta, we are going to take the complete section along the z-axis. This is my z-axis, x and y. That means I will take a complete circle like this. So a complete circle like this, where we know that theta will be from 0 less than theta less than 2 pi. That means we will take a complete circle like this, and we will keep it along the z axis at some angle, and then we will rotate from this to this. So we are going to rotate like this so that the upper part of the sphere will trace the above region, and the lower part of the circle will trace the lower region. Alright, so we are going to get some region like this, and now we need to determine at what angle we have to rotate this from this. Alright, so let's try to evaluate that. So this is my y, this is my z, this is my x plane. Okay, so for finding the angle, we will consider the yz plane. So in the yz plane, we know that x is going to be 0. So what will be this cone? So here we know the equation is z square is x square plus y square equal to 3. So in the yz plane x is 0. So we will get, so if I try to evaluate this z by y, so what is z by y? So we know that z square is equal to y square by 3, or z upon y is 1 by root 3, and that is same as tan theta, right? So that implies theta is, so when it is 1 by root 3 is at the angle pi by 6, right? So this angle will be pi by 6, this angle will be pi by 6. So naturally the other angle, that is this angle or this angle, will be pi by 3. Okay, so we have to rotate from minus pi by 3 to pi by 3 if we see, because this is our z axis. So with the positive direction of z axis, this angle is minus pi by 3, and this angle is plus pi by 3. Alright, so our phi will be minus pi by 3 less than phi less than or equal to pi by 3. Alright, so next is we will evaluate this with this limits, we will evaluate the integral, that is x square plus y square. So therefore we get triple integral s x square plus y square will become equal to triple integral. So x square is nothing but rho square cos square theta sin square phi plus, so y square will be rho square sin square theta sin square phi and multiplying by the Jacobian without fail, that is sin phi. Okay, so here we can see that rho square sin square phi is common. So this will be equal to triple integral rho square sin square phi, and inside we have cos square theta plus sin square theta. Then we have rho square sin phi, and combining everything this will be equal to 1. So finally we will be left with rho raised to 4 sin cube phi, and then we will take d phi first, d theta then, d rho then. Okay, and we know phi is from minus pi by 3 to pi by 3, theta is from 0 to 2 pi, and rho is from 0 to a. Alright, so now I will evaluate them one by one. So we can see that this becomes equal to 0 to a, 0 to 2 pi, rho raised to 4 is constant with respect to phi. So minus pi by 3 to pi by 3 sin cube phi d phi d theta d rho. Alright, so this is an odd function and minus limit to limit, that is always going to be 0. So the final answer turns out to be 0 in this case. Okay, thank you.